Hey guys, today we're going to do a lesson called Application of Quadratic Functions. This is a lesson that we actually added in a couple years ago because we noticed that students were able to uh, do everything that we asked them to do with the quadratic function, all the formulas on the formula chart. But when it came to application, we found that there was a hole there, a gap in understanding in regards to um, limits that are on a certain quadratic function that, well, let's just get on and I'll show you what I'm talking about, okay? All right, here we go. So we have in a situation, here's a real life situation. It creates a parabola. It is the height of the ball that is being thrown. So if you can think of, something going, it's going up and it's going down. And so and then we have this formula. So the quadratic equation, I just want you to just remember that when I'm defining the function, that is our y value. And so the h in the h represents our y, but it also represents the height of this ball that's going up into the air. If you can imagine the y-axis right here. So it is the height. And though I don't think it's stated in this situation, we're going to say it's in feet. And then the t is going to be our time, and it is going to be a representation. We're going to say it's in seconds. So if you can imagine, as time is moving on the x-axis, this ball goes up and then it comes back down again. And the y is the height of that ball. So what is the maximum height the ball reaches, and how long will it take for this ball to reach the ground right here? And how high is it going to get? Or actually, it says how long will it take for the ball to get to the maximum height? So they want to know when it's going to get right here. What time will it be? So if you remember some of our definitions, you might remember axis of symmetry. So we're going to actually use this formula to solve these questions. So I'm just going to go ahead and write it in right here to remind you what it is. And then I'm also going to remind you, I'm going to take this off right here, that A in this original equation is negative 16, B is 32, and C is 20, just so you know where I'm getting these numbers. And so if I have a negative b, that's going to be a negative 32, 2 times a negative 16. That becomes negative 32 over negative 32, which becomes 1. So x equals 1 second. So it's going to come up. It's going to be at its maximum point at 1 second. But what is that maximum point? What is y when x is 1? So I come back to the original equation, and this time I say, what is the y when x is 1? So I'm just going to replace all the all the x's with 1s. I'm going to work it out, and I'm going to get 16 plus 32 plus 20. That's a negative 16. And my final answer is 36. So it's 36 feet. So my maximum height is going to be 36 feet. And my, 36 feet goes up here. And the time it takes it to get there is 1 second. Okay, so what did we need to find? The vertex. This was all in the vertex, the h and the k. Now, how long will it take the ball to hit the ground? Well, the ball hitting the ground is where y, the height of the ball, is 0. So we're going to figure that out now. So what we're going to do is we're going to now substitute 0 into the equation. So the 0 is going to go to the far left, and then I write the original equation. So if you notice, we're just substituting in. Now, immediately I notice that there's a greatest common factor of -4. So when I pull that out, it makes the -16 positive. Then this becomes a -8t. This becomes a -5. All right. Now I'm going to factor it. So if you remember everything we learned about factoring, that A equals 4, B equals -8, C equals -5, A times C is a -20. I'm going to factor that out to get to -8. So I think of a -10 and a +2. All right. Now, here's where a lot of people make a mistake. A is not 1. A is 4. So I'm going to put a 4 underneath both of these. And this becomes -5/2. And this becomes 1/2. All right. I now need to set both of these. Now need to do bottoms up. So let's come back over here. I have 2x minus 5, and I have 2x plus 1. Okay, now, still not there. I have to find my solutions, I need to set these to 0, because when y is 0, x is our solution, or where it's going to cross over the x-axis. So first off, I have a -4. Well, it can't be -4 because -4 cannot equal 0. So that's out right off. So now I'm going to do the 2x minus 5 and my 2x plus 1. So let's do this one first. +5 plus 5. 2x equals 5. Divide by 2, divide by 2. X equals 5/2, which is 2.5 seconds. Let's do the other one. -1 minus 1. 2x equals -1. Divide by 2, divide by 2. X equals 1, a -1/2 second. Now here again, just like -4 wasn't a good solution, the -1/2 is not a good solution because we can't have negative time. So it cancels that whole thing out. So where the answer to this question is going to be 2.5 seconds. So the ball goes up and the ball comes down at 2.5 seconds. Now, you're probably thinking, how is that possible? If my axis of symmetry is 1, how can this be 2.5? Because isn't the axis of symmetry supposed to be straight down the middle? Well, let's check it out. So I'm going to go on down. And then it asks, what is the height of the ball at 0.5 seconds? So again, I can figure out where the height of the ball is anywhere at any time by just putting in x, which is time, into the equation, and I can figure out pretty much where that ball is at any moment in time. Not that there's much time involved here. So if I work it all out, I end up with 32 feet. Okay, now let's move on to this graph. So the x and the y are already labeled. We already know that that this -0.5 was one place and 2.5 was the other place. We also know that the axis of symmetry was right here, and we know that 36 was the maximum point. Now the 32, which is what we had a little while ago, was at 0.5 seconds. We knew that it was at 32, so we already figured that out. So we can also mirror that over on this side. So you can kind of see how y you ended up over here. Now the let's see. So the y-intercept is where x is 0, and I feel like we figured that out a little while ago, where x was 0. Did we do that on here? Let me look. X is 0. No, we don't have that on here at all. So we can figure that out. What is the y-intercept? So if I go back to that original equation and I say y equals negative 16, 0 squared. Well, actually, I don't even have to work it all out. I'm going to go back up here and just show you right here. Let me come all the way up, all the way up. Right here is our y-intercept, right there. So that's at 20. Okay, now you can see again, I'm going to go ahead and work over here, and we have our full parabola. No, my pen's not working. Here we go. All the way up. Ugh. It's the ugliest parabola I've ever seen, but you got it. The y-intercept is 20 feet. The zeros are negative 5, 0, and 2.50. The vertex was 136, and I was trying to erase that. Okay, so again, it doesn't make sense for the ball to go into the negative side. So at this point, you're kind of like saying, well, then why is it starting at 20? So that's something to think about. Our domain, remember, is our x values. And so we'll call it t, not x. T. It's from 0, because we can't go negative with that. Even though it's negative on the parabola, it doesn't make any sense. And the range, I know it doesn't start at 0, but it ends at 0, so it is part of our range. So then the question might be, why is it that it's starting at 20? So you have to think about it. What is it? Is it somebody standing on a platform or something like that? So those are the kind of questions that you can look at that and say, well, I have a problem with this, but it's starting at 20 at 0 seconds. So the person must be standing on something in order for this to work out. Can't use negatives. Do not use negative time. And I'm not gonna go ahead and work this out because I'm running out of time here, but I will answer the question. And 1.75 seconds. Okay, I'm gonna stop so I'm not out of time. I'll see you later. Bye-bye.